Fly me to the moon, let me play among the stars, and let me see what spring is like on Jupiter and Mars.
As we regain the spirit to go amongst the stars to discover new worlds, many countries are now trying to return to the moon. Join Mighty Meat Media as we look at the second iteration of the space race with more competitors and more interesting and innovative ways to explore our home moon. And we are go for launch. 3, 2, 1, ignition. We start with the only country to ever send astronauts to another heavenly body. We start with the Americans, with the NASA program and the Apollo program of the 1960s and 70s. They paved the way for lunar exploration and are doing so once again with the Artemis program.
5, 4-stage engine start. 3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Engines on the core stage and 2 solid rocket boosters now propelling the vehicle at 128 miles per hour. Hearing good control on the roll from teams in Mission Control Houston. All good calls so far. Now 30 seconds into the flight of Artemis 1. First milestone will be for the vehicle to pass through max Q at about 1 minute and 9 seconds into launch. This is the greatest period of atmospheric force on the rocket.
So let's start with the ride that's going to take the astronauts to the moon from the United States NASA program with its international partners. First, it will be the SLS, or Space Launch System, designed and developed by NASA. The SLS will have 4 RS-25 engines. RS-25s are the engines that were originally designed and built for the space shuttle. They repurposed them and reused them for this particular rocket. So we also have 2 strap-on solid fuel boosters on either side of the rocket. The rocket burns liquid oxygen and liquid hydrogen for a clean burning and power dense mixture. Some of the numbers: the SLS Block 1 will be 5.75 million pounds at liftoff, completely fueled, and it will stand 322 feet tall. Its cargo volume will be about 22,000 cubic feet. So the Block 1 is capable of lifting 154,000 pounds to orbit, and it makes about 8.8 million pounds of thrust at liftoff. So the original budget for the entire Artemis program was about $18 billion with a B. So the Artemis program costs about $4 billion every time they launch SLS. It is about $6 billion over at about $24 billion right now, and it's expected to reach $93 billion before we land a human on the moon. It is about 6 years behind schedule as well. NASA, however, is not going this alone. They have many international partners, to include the European Space Agency, the German Aerospace Center, the Japanese Aerospace Exploration Agency, the Canadian Space Agency, and several commercial partners as well. I think it's covered with bureaucracy. I think it's the United States government program. It's way cost overrun. There's not very many technical innovations, and they haven't leaned heavy enough on their commercial partners, which I thought was what was going to set this apart. I'm excited to see it. I want to see the United States go back to the moon, and I want to stay there for good. But I just don't know if this iteration of Artemis will complete that mission.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़.
The nation of India is next up and new to the scene of landing on the moon. They've done incredible with the success that they've had with this specific rocket setup, and they successfully landed.
5, 4, 3, 2, 1, 0. Plus 5 seconds.
Lift-off normal.
Here we have a majestic liftoff of LBM-3 M4 rocket carrying India's prestigious Chandrayaan-3 spacecraft.
P2 tracking.
प्रज्वलन और सफलतापूर्ण उत्थापन LVM-3 M4 रॉकेट का.
So this was a great technological achievement by India. They had an unconventional way of getting there that I wasn't terribly excited about, but they were successful. This has a relatively short mission profile, 1 lunar day, which equals about 14 Earth days. It will remain on the surface of the moon, but will not be operational after that 2-week time frame. The launch vehicle M3 is the one that gave the ride to the Chandrayaan-3 rover to the moon. It's fairly new. Its first orbital flight was in 2017, so it's brand new on the space market. It is a pretty big rocket. It's 142.5 feet tall, 13 feet in diameter, and its mass is about 1.5 million pounds. It's a 3-stage rocket that can take 22,000 pounds to low Earth orbit. It has quite a bit of thrust too. It's not traditional, so you have the 2 first stage boosters, and then you get into a second stage, which actually runs simultaneous with the first stage, but burns longer. You're comparing apples to oranges with the passengers or crewed missions from the United States to a rover from the country of India. However, it's significantly cheaper. So it's about $63 million for a launch of the rocket, and the rover was about $30 million. So they're about $93 million in, where the United States is $93 billion.
We are in the powered descent phase, and we are in the rough braking phase, which is the first phase of the powered descent. We have currently traveled a downrange of 697 kilometers, and the downrange that has to be traveled during this phase is 713.5 kilometers.
जी हाँ, अभी आप देख सकते हैं कि लैंडर की हॉरिजेंटल वेलोसिटी लगभग 720 मीटर प्रति सेकंड हो गई है. लगभग हम ये कह सकते हैं कि 900 मीटर प्रति सेकंड वेलोसिटी को कम किया जा चुका है. At the same time, we can see the altitude of the lander is just 17.8 kilometer from the moon surface, which is going to be around 7.4 at the end of the rough braking phase.
इस फेज के बाद हम जाएंगे towards the attitude hold phase, where we will be expecting sensor update from the laser and car band altimeters. We can see the visualization of the lander module moving towards the moon's surface. The current altitude is nearly 15.2 kilometers, and the distance traveled is 754 kilometers. We can also see the image that the lander imager camera has been providing.
जी हाँ, इस रफ ब्रेकिंग फेज के दौरान 800 न्यूटन के चारों थ्रोटल इंजन अपने कार्य को पूरी तरह से अंजाम दे रहे हैं और लैंडर के हॉरिजॉन्टल वेलोसिटी को लगातार कम कर रहे हैं। अब तक लैंडर लगभग अपने 75 से 80% की यात्रा को पूरा कर चुका है।
After the rough braking and the attitude hold phase, we shall be having the fine braking phase, which will continue for nearly 3 minutes. The whole phase is being driven by the autonomous landing sequencer and there is no intervention from ground.
जी हाँ आरुषि, अभी आप अपनी स्क्रीन पे देख सकती हैं कि जो करंट आल्टीट्यूड है चंद्रमा के सतह से लगभग 10 किलोमीटर के आसपास है। जी हाँ, हमारे प्रधानमंत्री जी श्री नरेंद्र मोदी जी हम सभी का उत्साहवर्धन करने के लिए दक्षिणी अफ्रीका के जोहानसबर्ग से जुड़ गए हैं।
Yes, we are privileged to have with us Honorable Prime Minister of India, Shri Narendra Modi ji, who has joined us from South Africa's Johannesburg to encourage us.
जी हाँ, आप ये देख सकते हैं एल्टीट्यूड होल्ड फेस भी बहुत ही आसानी से लैंडर फेस ने पार कर लिया है और अब फाइन ब्रेकिंग की शुरुआत हो चुकी है। अभी हम ये देख सकते हैं कि लैंडर की ऊंचाई लगभग 5.6 किलोमीटर है, जो कि इस फेज के उपरांत लगभग 800 मीटर हो जाएगी।
We can hear from the mission operations team that the sensors are performing nominally. And we are currently in the midst of the fine braking phase, which is going to continue for 3 minutes. And the altitude is going to be reduced to nearly 800 meters at the end of this phase.
जी हाँ, जैसा कि आरुषि जी ने बताया कि लगभग 3 मिनट के उपरांत लैंडर की हाइट लगभग 800 मीटर वर्टिकली होगी और यहाँ पे लैंडर की हॉरिजेंटल वेलोसिटी, वर्टिकल वेलोसिटी, इवन डाउन रेंज भी लगभग शून्य होगा।
We can see the visual of the lander module and we can see that the down range traveled is nearly 831 kilometers.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि लैंडर की ऊंचाई अब चंद्रमा के सतह से लगभग 3 किलोमीटर से कम हो चुकी है।
We are very close to the moon's surface, nearly 2.6 kilometers as we can see.
जी हाँ, अभी आप देख सकते हैं कि लैंडर की ऊंचाई लगभग 1 किलोमीटर के आसपास है।
We are nearing the final phase of the power descent, which is going to be the vertical descent phase or the local navigation phase.
जी हाँ, अब हम फाइन ब्रेकिंग वेज के एकदम करीब आ चुके हैं। हाँ, आप तालियों के गड़गड़ाहट से सुन सकते हैं कि हम लोगों ने तीसरे चरण को भी बहुत ही सफलतापूर्वक हासिल कर लिया है और अभी हम वर्टिकल डिसेंट फेज में आ चुके हैं, जिसकी शुरुआत भी बहुत ही अच्छे ढंग से हो चुकी है।
Lot of applause indicates that till now the performance has been nominal. We are in the vertical descent phase 1. The altitude is being brought down from 800 meters and we are nearing and approaching the lunar surface.
जी, आप अपने स्क्रीन पे देख सकते हैं कि लैंडर का हाइट लगातार कम होता जा रहा है। इस समय हम लैंडिंग साइट के जस्ट ऊपर हैं और इस समय इसकी ऊंचाई लगभग 600 मीटर के आसपास है। इस फेज के दौरान लगभग 150 मीटर के ऊंचाई पे पहुंचने के बाद लैंडर अगेन लगभग 20 से 22 सेकंड के लिए हॉवरिंग करेगा।
We are above the landing site. The horizontal as well as the vertical velocity is now being constantly reduced. And the lander module has begun its descent towards the landing site.
जी हाँ, आप अपने स्क्रीन पे देख सकते हैं ये जो पथ निर्धारित किया गया है, लैंडर पूरी तरह से उसी को ही फॉलो कर रहा है। इस समय हम लगभग 200 मीटर की हाइट से भी कम आ चुके हैं। अब हम ये देख सकते हैं कि हम लगभग 150 मीटर की ऊंचाई पे हैं चंद्रमा के सतह से।
We are approaching the vertical descent phase 2, which will have the lander module hovering at nearly 150 meters above the lunar surface.
जी हाँ, आप इस तालियों के गड़गड़ाहट को सुन सकते हैं, जो कि सेकंड हाइब्रिड फेज के कंप्लीट होने के बाद इन सारे वैज्ञानिकों के द्वारा की जा रही है। जी हाँ, आप अगर फिर से ध्यान से देखें तो एल्टीट्यूड पुनः कम होता जा रहा है। अभी हम लोग लगभग 135 मीटर की ऊंचाई पे हैं।
The sensors that are updating at this point are providing confirmation of the safety of the landing site.
As expected, the retargeting is going on and this is a very good signature for the lander. अभी आप ये देख सकते हैं कि लैंडर की ऊंचाई लगभग 65 मीटर के आसपास बची हुई है।
Currently, only 2 engines are now being fired, and we are nearly at zero velocity, vertical and horizontal. We were hovering, and now we are approaching the moon's surface.
धीरे धीरे लैंडर की वेगमान को कम किया जा रहा है और हम अब लगभग 50 मीटर से भी कम आ चुके हैं।
We can see the Honorable Prime Minister, Shri Narendra Modi ji, who is here to encourage us, and he is critically looking at the visuals.
जी हाँ, आप अपनी स्क्रीन पे देख सकते हैं कि हम लैंडर मॉड्यूल
People are applauding. Let us all wait to hear from the Secretary Department of Space and Chairman ISRO, Shri S. Somnath.
लैंडर मॉड्यूल पूरी तरह से सेफली और सॉफ्टली चंद्रमा के सतह पे लैंड हो चुका है। ये हम लोगों के लिए बहुत ही गर्व की बात है। हिंदी में एक कहावत है कि चंदा मामा दूर के, लेकिन अब हम ये कह सकते हैं कि चंदा मामा अपने घर के।
बहुत ही उम्दा. The hard work of the entire ISRO community has come to fruition.
So what is there to say? I mean, I think that it was interesting. Their orbital tract. You saw me do simulation using KSPE. I thought it was a lot of unneeded and extra movements and made it very difficult to actually pull it off. But they did. They landed on the moon. Hopefully, we'll get some good science, and it's really cool. It's really interesting to see another country doing it non-conventionally, and the price was right. I mean, under $100 million to land on the moon and get some valuable data. So, good job to the Indian space program, and look forward to seeing more from you. Great job, guys. Great job. The Russians, of course, lost the United States in the space race, but were also first to many milestones in it. They did crash this specific one, but there'll be another.
Пуск. Параметры системы управления ракетоносителем. 20 секунд. Двигатели первой и второй ступени работают нормально.
So the Russians use a rocket, a proven and well-tested rocket called the Soyuz, and this is the Block 1B version. The mission carries Luna 25, so the 25th trip to the moon. The Soyuz hasn't changed much overall. It's had upgrades in different blocks, but it's been about the same rocket. It's a 3-stage rocket. It uses liquid oxygen and RP1 or kerosene. Its full mass is 94,000 pounds. And it has a diameter of about 9 feet and a length of about 64 feet. So smaller than the other rockets. It has a few different engine designs based on application, and it's a very reliable rocket. So one of the coolest and most iconic things in spaceflight is the Korolev Cross from the Soyuz spacecraft. The Luna 25 mission cost the Russian space program about $200 million. Not too bad. Not much to say. It did fail. We'll look a little deeper into that with this simulation. So, to my best guess and knowledge, based on the information that's been released by Roscosmos and the information that I've read from the Russian government, is the Luna 25 mission reached orbital inclination around the moon, so got in orbit around the moon. It seems that they were trying to remove the eccentricity from the orbit so they could start slowing down and getting down towards the surface to land successfully. There was a counteract when they broke apart the staging to bring it down to the surface. There was also a miscalculation in the gravitational pull of the moon. So when that happened, when you are doing something with a rocket, you always aim towards the horizon because all orbit is continuously falling. So you're counteracting the fact that you're moving quickly with the fact that you're falling towards gravity. So you have to get that balance, and that's essentially what an orbit is. So what we have here is them trying to boost towards the horizon and miscalculating the gravity. Once they realized that they got into trouble, they probably likely started tumbling again based on the gravitation and where they thought the orbital inclination was. And that caused it to further spin out of control, be far away, and then we started seeing this big burn to try and push it out of the lunar orbit. Now, if they would have been successful, it probably would have shot all the way out into space and been lost potentially. But instead, it broke up and smashed into the surface of the moon at a very high rate of speed. Although it's a disappointing failure and it could have implications with China, I think that Russia will fix their error and they will make another attempt to land on the moon and then eventually bring humans to the surface of the moon, like all the rest of the countries. The space race is real. The Chinese program has been very interesting. They've had some incredible things happen, but under the veil of communism and the fact of the political tensions, not many people have heard about the amazing things they have done.
5、4、3、2、1，点火，点火。起飞，起飞时间：动4时3度分2幺秒，发动6毫秒。程序转弯，阵地112跟踪正常。文昌光学雷达跟踪正常，遥测信号正常，文昌飞行正常。总部岭遥测信号正常。文昌雷达跟踪正常，遥测信号正常，文昌飞行正常。阵地遥测信号正常。阵地315跟踪正常。317跟踪正常。 零水3901跟踪正常。文昌雷达跟踪正常，遥测信号正常，文昌飞行正常。铜鼓岭遥测信号正常。助推器关机，助推器分离。抛整流罩。文昌雷达跟踪正常，遥测信号正常，文昌飞行正常。一级关机，一二级分离。二级依次关机。二级二次点火。二级二次关机。器件分离。
The Chang'e 5 mission landed in 2020 on the dark side of the moon, and it was a sample return mission. So a rover landed and returned samples to Earth for study. They used the Chinese Long March 5 rocket for the Long March 5, or Shenzhen 5, is China's heavy lift rocket. It is currently the fourth largest rocket in the world in operation. It stands at 186.9 feet. It is 16 feet in diameter and has a full mass of 1.9 million pounds. It can take about 55,000 pounds to low Earth orbit. It is their first rocket that uses non-hypergolic fuel. It has several stages, including 4 boosters that use solid propellants. Then it has a first, second, and optional third stage. It's relatively reliable, with only 1 failure on its entire record. For a mission that landed on the moon, scooped samples and returned those samples safely back to Earth, although only 2 kilos of sample, the price was relatively reasonable, about $230 million US. So I think that everything being equal, the Chinese space program has had some amazing feats. For one, it's incredibly difficult to land on the moon, as we just saw with the recent Russia program. But then it's even more difficult to then take that lander, fill it up with samples, and then get it back to Earth safely. So it's really quite an incredible technological feat. They also have plans to take humans to the moon by 2030, so that would be interesting as well. I think there's a lot of benefits and positivity going into the Chinese space program. Of course, it's different, political tensions and all that good stuff, but it's good to see something moving in that direction. Really excited about what they're doing and how it puts pressure on other countries to develop their own programs and develop their own ways and innovations to be able to do it. The recent Russian failure on landing on the moon has put in jeopardy the Russian-Chinese partnership. So it will be interesting as well to see how that all unfolds.
Okay, Houston, Challenger's at 2 minutes and 50 seconds.
Roger, Challenger, everything looks great down here.
Correct. Okay. I'm not going to be able to squelch him out anymore. Okay? Turn the volume down a little bit. Reading you loud and clear, America. This is Challenger. We're coming up on 2:10 from liftoff. We'll be with you shortly. Okay, Jack. Double check your logic power breaker. Check. Okay, master arm is on. I've got 2 good lights. Same arm. I've got 400 plus 1 in. Okay. My watch is reset. Okay, you got 367. You want to pick up the camera just before I hit abort stage. One minute coming up, Gene. Take your final look at the valley of Taurus Littrell. Up from orbit. Okay, 1 minute, Houston. We're 50 seconds now, and we're go.
Roger, you're looking good here.
I'll get that at 30. Okay? Camera's not going to run without me holding it. The average D, 20 seconds. Ah, shoot. Okay, let's get off. Forget the camera. Okay, 10 seconds. 10 seconds. Port stage pushed. Engine arm is S. Okay, I'm going to get the pro. 99, proceeded. 3, 2, 1. Ignition. Right away, Houston. Regs are good. Ag saw it. Pitch over.
Roger, you have good thrust.
Okay, 30 seconds. 308 your number. Okay, coming through 1,500 feet, and H-dot looks good.
Roger, we've lost data right now, but we'd like aft Omni, please.
Okay, coming up on 40 seconds in, we're going. Coming right over top of Camelot. Awful lot of static, Jack. We break lock? Yep. Why don't you get it on an Omni or something? Yeah, I got it on the Omni.
1 minute, 1 minute. 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 1
See if you can get comm back. Hello, Houston, how do you read?
Roger, Challenger, you're loud and clear, and both systems look good. You're right on the line.
Should be about 145 and minus 47. See if we can get comm. I will. Houston, we're in the blind and we're go.
Roger, we'd like the Ags to auto.
Okay, I got good luck. No. Trying to hold. Okay, Houston, coming up on 2 minutes.
Challenger, Houston, your go at 2 minutes. We'd like Ag smoke control auto. Over.
Okay, you watch the table, Gino. I'm watching it. Just get calm if you can.
Challenger, Houston, how do you copy Houston?
Okay, Houston, Challengers go. Coming up on 2:30. We're through 19K.
Roger, Challenger, we need a 623 plus 10,000 in the Ags. Over.
Well, those are the angles. How about an Omni? I tried it. I've got
Challenger, Houston, aft Omni, please. Would you relay America?
Okay, Houston, 3 minutes. The Challengers go. We're through 25K. I tried it. I tried it around and it doesn't hold. Try aft Omni again. Doesn't help.
America, Houston, tell Challenger that they're right on the money on trajectory. Both systems are go. Over.
Okay, Houston, in the blind. Challengers go. Coming up on 325, 30K. Okay, there's aft. How do you read, Houston?
America, would you relay to Challenger to go aft Omni?
We are aft Omni.
Okay,
how do you read?
they are in aft Omni right now.
Okay, America, tell Challenger we're reading them 5 by.
And we move towards a new era of spaceflight, all seeking the same prize, the moon. And boy, there's a lot of prize to be had there. And I cannot for one wait to take a vacation one day to the moon. Good luck and Godspeed to all trying to get to the rocky lunar surface. Good luck, everybody.